Okay, good morning. Happy Monday. We're going to be doing classwork 7, which is the surface area and volume of pyramids. So we're going to do a little prior knowledge just in, I know we haven't done pyramids, but we could find the height of this pyramid. So remember, who's our pal that helps us with height? That is Juan. And there's Juan, and he is standing at the top of the pyramid. And when we want to find the height of the pyramid, we drop Juan's little rock straight down to the center point. So notice how along the base of this square pyramid, we have a side length of 6. Well, clearly we want half of that. So if we were to redraw the triangle that Juan is standing atop of, our base of that triangle is 3, and this 10 is our hypotenuse, and we are looking for our altitude. So this 10, I'm going to draw a triangle over here. All the faces of our pyramids are going to be triangles, and those triangles are going to have their own individual height. So the height of a triangle face we call the lateral slant height. So 10 is L for lateral slant height. Okay, so we have A for altitude, and this fancy L for lateral slant height. Of course, B for the little base. And so the height of this pyramid, A, using Pythagorean theorem, 10 squared minus 3 squared. And if we plug it into our calculator, A is approximately 9.54 feet. Surface area of a pyramid. So the figure above is a square pyramid, and we can make a net of that pyramid, and we can add up all those triangle faces and our square base. So area of a square, let's see, let's go ahead and label this first. This height of our triangle here, where the arrow is pointing, that's 10 feet. Now again, the lateral slant height and the altitude are not going to be the same. All right, so that's 10, this is 10, right? Because they are congruent, because the base of the pyramid is regular. It's a square. So you need to determine, are all my rectangles going to be the same? Is my base regular or is it not? So we can think of some shapes, trapezoidal pyramid, where our triangle faces might not be the same size. Even with a rectangular pyramid, our triangles might not be the same size. So here we go. Side length of the square is 6, so area of the square is 6 squared, or 36. And we have 1, 2, 3, 4 congruent triangles. So the area of 4 triangles is 4 times the 1/2 base of 6, and our height of 10. So the height of the triangle, that's the face, versus the height of the pyramid, which is at 9.54. So our total surface area is going to equal 156 feet squared. For our next problem, we have a hexagonal pyramid. And if we were in class, we would do a lot of whiteboard work and we would talk one-on-one about, or as a class about what we were looking at. But that's a little hard here. So I'm just going to, for the sake of time, see how they gave us 5? That's the apothem for the hexagon inside one of the equilateral triangles. That's the apothem for that. So for the sake of time, I'm going to tell you that the side length, the side length, so each length of the hexagon is going to be 5.77. And the area of the hexagon is 86.55. So what are we doing here? Notice how we have a triangle inside where A equals 12. And the base of that triangle, the apothem, is 5. Well, we know that when we are finding the surface area of a pyramid, we know that we need that slant height, L. That's slant height. So using Pythagorean theorem, I'll just tell you L is 13. All right, so if we were going to find the surface area of this hexagon, our surface area equals that hexagon base, 86.55, plus we're going to have 6 triangles that are all the same. 6 times 1/2, the base of 5.77, times the lateral slant height of 13. So plugging it into our calculator, the total surface area of the base hexagon and the 6 triangles, our surface area is 311.58. We'll practice more with those, but basically area of the base plus area of all the triangles. All right, I'm going to do something. I practice this and let's see if we can do this. I unshare my screen. I'll wave at you. There I am. And then I need to reshare my screen. Here we go. And all right, back at me. World's cutest cat. And we're back to sharing screen. Here we are. All right. Compare the height of the pyramid to the height of the prism. What did you notice in this case? They are the same. And compare the base of the pyramid to the base of the prism. What did you notice? Those two are the same. And filling the pyramid with water, how many pyramids did it take to fill the prism? It took 3. So, suppose a pyramid has a volume of 300 cubic units. What would be the volume of the prism? So, we know then that the volume of the prism is 3 times the volume of the pyramid. I forgot anything. And so we know that the volume of the prism is going to be 3 times 300, or 900 units cubed. So suppose a prism has a volume of 60 cubic units. We're going to have 60 cubic units. And we want to know what the volume of the pyramid is. Well, that would be 60 equals 3 pyramids. Trying to write with the cat on my lap. Wouldn't the volume then be 20 units cubed? So if we want to find the volume of the prism, we find the area of the base and times it by the height. So that's going to be our prism. If we want the pyramid, we take the volume of the prism and simply divide by it. So that's essentially what our formula is. If you look up on Google, you're going to get all sorts of crazy formulas. Let's just make sure that we understand what we're doing. We know the prism is just the area of the base times the height. If we want the pyramid, we just want 1/3 of that. So if we see this pyramid and it's 20 cubic feet, I know 3 of those pyramids fit in that prism. And so the volume of the prism is going to be 3 times that 20, which equals 60 units cubed. We got a couple of try these, so I'm going to do these quickly with you. We have a square pyramid below. Its base edges are 7.5. We know that it's got a slant height of 12. And so we're in business. Area of the square is 7.5 squared. Area of the 4 triangles is 4 1/2 base times height. 7.5 times that lateral slant height of 12. Plugging it into our calculator, our surface area is going to be 236.25 feet squared. Volume of the square pyramid. Well, for volume, we need the altitude, right? We need Juan's help. And so we've got this triangle inside, and we know the lateral slant height is 10. And if the whole base is 12, we want half of that, right? 6 and 6. So we want 6, and using Pythagorean theorem, I can find the altitude A equals 8. To find the volume then, it's the prism, base times area of the base times the height. So 12 squared is my base times my height of 8. That would be the prism that made that up. If we divide it by 3, we get the pyramid. So my volume is 384 inches cubed. So here's some notes to consider. To find the surface area of a pyramid, you will need to find the area of the base. And to that, you need the individual areas of the triangles that make up the lateral faces. Remember, if this was one of the faces, that's L, or lateral slant height. And to find the volume of a pyramid, you need to find the volume of a prism that has the same base and height. And once you know the volume of that prism, you simply divide by 3. All right, and for volume, you need A, your altitude. So surface area, you need L. The lateral slant height. And for volume, you need A, the altitude, or the height of the whole pyramid.